Hello friends, so now we will cover the RAM 8 chip, the RAM 64 and the RAM 512. So the RAM 8 chip consists of 8 registers. It's a memory chip that consists of 8 registers that are capable of holding 16 bits each chip with their respective address and the respective load. As you remember, in the register requires a load, an input, and it gives us an output depending on the load. So if the load is 0, we'll get the previous result. If the load is 1, the input gets carried into the output. So if you notice here, it's a similar case. The RAM 8 chip has input, which is going to be of 16 bits, address, which is going to be of 3 bits, and the load of 1 bit, and basically 8 registers inside. And the output will be 16 bits. So if you want to write from into the RAM, you assert the load to be 0. If you want to write into the RAM, you assert the load. If you want to write into the RAM, you assert the load bit to be 1. And if you want to write into the RAM, you assert the load bit to be 0. And the address is 3-bit, as we mentioned before, with 8 different addresses for writing and reading. So this address, that's 3 bits, will need to be asserted in each register. So each register needs to take a bit from this address. But since the address is only 3 bits, then we will need to figure out a way to make that happen. So how can we make that happen? If the address is the function and we have one load will take in three selectors and needs to give us 8 outputs that will be asserted in each register. So this describes exactly what a DMUX 8-way is. So DMUX 8-way gates takes in one input, 3 bits selector, and it gives us the output of 8 outputs. Each one can be 16 bits. So let's go back to our RAM 8. So that way we've already figured out how are we going to do that is through a DMUX 8-way selector. And then once we have the result for each register, how are we going to turn it into an output, one output? Because we don't have 8 outputs or 8 output of 16 bits. We only have one output of 16 bits. So the way to do that is with a MUX 8-way 16. A MUX 8-way 16 takes in 8 inputs, and using 2 selectors, it gives us output which is 1. Using 2 for 1 multiplexer and only 1 to 1 multiplexer. Anyways, this is not our story. Our story for now, our focus is RAM 8 chip. But we will definitely need to use a DMUX 8-way and a MUX 8-way 16 to be able to solve this problem. So let's look at the solution. Let's build the solution together. So you will go to your IDE in the hardware simulator. And first, we need to turn the load into 8 loads. So the way to do that is go through DMUX 8-way. And in the input, we will have our load. In the selector, since the selector needs to be 3 bits, then we will have our address. And the input is going to be load 1, load 2, all the way to load 7. Sorry, let's make load 2, load 3, and then will be load 4, load 6, load 5, load 6, and load 7, and load 8. Now we have 8 loads. We will need to figure out how we can put them into a register. So if you remember, our register takes in an in, a load, and an out. The in should always be our input, because that's what goes through the register. The load is going to be each of these loads. So load 1 will go through first register, and the out will be, for example, we'll call it register 1, okay? And we will repeat this over and over again for each load. We'll just change 2, 3, 4, 5, 6, and we need another one, and 7. We'll do the same thing for the out, R2, 3, 4, 5, 6, and 7. So now, as I mentioned before, we need a multiplexer that will collect our results of these registers and turn them into one result. So the way to do that is with the mux 8-way 16. So the mux 8-way 16 will take R1, R2, R3, R4, R5, R6, R7, and R8. And the selector, of course, is going to be our address, because mux 8-way 16 takes in 3-bit selector. And then the out will be our out. So as you can see here, we can test our register. So now let's look at how we can apply this in Logism or any other software out there, for example, digital. So first our load goes through a demux, which gives us 8 loads, and the input goes through each of the 8 registers that we have. This is why it's called RAM 8, because we have 8 registers, and the loads will be asserted as loads in the register, and they will go through a mux 816, which will take in our address as well, just like the demux took. The demux 8-way and the mux 8-way both took the address being our 3-bit address, and then the result of that will be out. Now let's move to the second bit, RAM 64. The second chip in this video we'll cover is RAM 64. So RAM 64 will have a similar solution to the RAM 8 chip. Instead of using a register, we will use 8 RAM 8 chips. So that's what we'll be using, and multiplexer and demultiplexers again. So let's look at building it first, so we have a clearer idea of how it works. So RAM 64 has an input of 16 and an output of 16 bits, and the address is going to be I believe 5-bit address, 6-bit address, so 6-bit address, and then we have load being 1 bit. Okay, so here, as you can see, we'll have a demultiplexer that will take in our load and will turn it into 8 loads for each of the RAM 8. Each of the RAM. It's just replacing registers with RAMs again, and this way now we will have 8 loads for each RAM. Naturally, we will have to building these RAMs, and these RAMs will take the input, and then we'll take the load with the address being from 0 to 2 instead of the address being 3 to 5. And then it will give us an output, which again will go through a multiplexer, and this multiplexer will take the address 3 to 5. So the question here is which address goes to where, and that's what we will be using here. So the address will be split into 2, first 0 to 2 and then 3 to 5. Because a demux 8-way needs 3-bit address, and a mux 8-way also needs a 3-bit address. However, the RAM needs a 3-bit address as well. So in total, it's going to be 6-bit address. So that's what we will figure out. So dmux and mux will always take in the same address bits. So the same address bits will go through a dmux, which is from 3 to 5, and it will go through the mux. However, when it comes to the RAM, it will take in the first bits. So just like with solving the last problem, we'll start from a dmux, and then, dmux 8-way. And then we will have at the end a mux 8-way 16. So this is the beginning, is like splitting our load, and this is merging the output. Okay, and in between here we will have RAM 8 sequence. So it will be a sequence of RAM 8, sequence of RAM 8, so we'll have 8. Okay, so here we'll take in the load, input being load first, and the selector, it will be address 3 to 5. And the output, we can call this L1 all the way to 8. So the RAM will take in each of these, the input being our input, the load will be L1, and the address is not going to be 3 to 5, instead it's going to be 0 to 2. And anyways, so, and then the mux will take in, of course, this R, this results are RAM 1, the result of RAM 1, the result of RAM 2, all the way to the result of RAM 8, R4, R6, 5, R6, R7, and then R8, and of course the selector will be the same address as the first selector, as the first selector of the dmux, and the output, that will be our out, our main out, now that we've merged it. And as you can see, it perfectly worked, and from what we remember here is it looks exactly the same as RAM 8, but this set of registers, this time we have RAMs, and this will be the same for RAM 512. RAM 512 has the same instructor, but instead of using RAM 8, we will use RAM 64, and instead of address 6 to 8, instead of address 3 to 6, we will use 3 to 5, we will use 6 to 8, and instead of 0 to 2, we will use 0 to 5. So all of these are kind of the same. RAM 8 relies on registers, RAM 64 relies on RAM 8, and RAM 512 relies on RAM 64. And of course, with the help of a dmux and the help of a mux and dmux at the beginning to branch out all the loads of each RAM or each register, and the mux at the end to take out the results and merge them into which one is going to be the result of the out, to make sure that we are able to select. And of course, the first bits of our address will be used for the RAM, and the last bits of our address will be used for the dmux and the mux. Make sure you don't mix that. So for now, we have covered RAM 8, RAM 64, and RAM 12, RAM 512. And for the next video, we'll cover RAM 4 and RAM 4K and RAM 16K. Thank you for watching, and if you are interested in the next video, please watch that.